Hey, this is Mr. Hansen. I wanted to work on the idea of compound events today, so we're going to be talking about that. That means the probability of either having one event happen or the other event. So that's what we're looking at. We're going to start with a scenario of 200 people were surveyed, and the results are given in this Venn diagram. So just a reminder, 100 people. Oh, and they were surveyed. The question was, do you belong to the French club? Do you belong to the Spanish club? And or and they could check mark both of those, or one of those, or neither of those. So that's kind of how that works. And so let's just do some singular probabilities first. So the probability of people belonging to the French club is 30 plus 10. That's that complete French circle out of, and the total sample space 30 plus 10 plus 60 plus 100, that's going to be 200. So 40 out of 200, 40 out of 200, and that breaks down to 20%. Probability of being in the French club is 20%. So the probability of being in the Spanish club, we've got 60 plus 10, that's 70 out of 200, 70 out of 200, and that breaks down to, about 35%. Okay, so now the question is, what's the probability that if you picked someone at random, they'd belong to either the French club or the Spanish club? So I'm going to write it like this: probability of French union Spanish. Okay, so that U means union, and that's just saying they're in some kind of a foreign language club, either French or Spanish. And so maybe you would think at first, well, we could add up the 20 and the 35, and we get 55%. There's a 55% chance that they're either in French or Spanish. You can kind of see what I'm saying, the 20% in French, 35% in Spanish. But there's a problem here, and we need to address that. There are some people that are in both, so we've counted them twice. So let's do this. We're gonna go the probability that they are in French club, and I'm just gonna do it as a fraction. 40 out of 200. Plus the probability that they're in Spanish club. That's 70 out of 200. But then we have to minus the probability that they're in both, because we've counted it twice. We've counted in the French and in the Spanish. So we're going to minus 10 out of 200. Okay, so let's go ahead and add this up. 40 plus 70 is 110, minus 10 is going to be 100 out of 200, which is 50%. So you can see that the 50% is not the sum of these two in this particular situation. Okay, so let's see if we can kind of look at this in a two-way table as well, so you can see what's going on. So let's probability of French and Spanish. Let's just put there 10 people there, and then no French and Spanish. That's going to be 60, and no Spanish but French. That's going to be 30, and then neither. That's going to be 100 there. So hopefully you can see these four numbers, how we got them from these four numbers over here. Okay, so let's kind of finish this table off. We know that there's 200 in all, and we know that the French total is 40, and we know that the no French is going to be 160, the complement of French. We know that the Spanish is 70, and no Spanish is 130, something like that. Okay, so let's just kind of see. I'm going to kind of circle these right up here and see if we can find them. Well, right here, see if we can find them inside the table. So the total Spanish speakers, 70 out of 200. Let's kind of just do that in red, this total Spanish speakers. So 70 out of 200. Plus the total French speakers, let's kind of do them in green. So 40 out of 200. So plus 40 out of 200. Minus this guy right here, and I'm going to just do him in yellow, minus that guy right there, 10 out of 200, because this is the guy that was counted for both. You can kind of see that he's called a joint frequency. He's counted for both the Spanish and the French. So we don't want to count him twice. We have to take him out for once. Okay, so we end up with the same thing in this table here. So let's just go over a little bit of notation, kind of finish this off, and then I've got one more example for you. So probability of French union Spanish equals the probability of being in French club plus the probability of being in Spanish club minus, and I'm sorry I'm running out of room, I'm going to put it down here, the probability of being in French and Spanish together. This is how you write and. It's intersect. It means intersect because we're kind of intersecting at the French and Spanish there. It's a joint frequency. So the probability of being in French or Spanish club, picking someone that's in one of those two clubs, is the probability of being in the French club plus the probability of being in the Spanish club minus the probability of being in both clubs. Okay, so let's look at one other example. This time I'm going to draw my Venn diagram, and okay, let's say this is a 7th grader. You survey people, and there are 7th graders and 8th graders that answer this survey. And so we're going to write maybe there's 40 7th graders, and maybe there's 50 8th graders. What would you put right in here? Can you have a 7th grader and an 8th grader at the same time? And the answer is no, they have to be either one or the other. So this is actually a bad way to draw that diagram. I'm going to draw it a little differently now. I'm going to do it like this. So 7th, 8th. So they're not overlapping. So maybe we had 40 here and 50 here. So the probability, and let's just say that maybe there was 100 people in the survey, okay? Or I'm sorry, there's 10 people that were neither 7th or 8th graders. So there were 100 people in the survey, something like that. Okay, so this is called mutually exclusive events or disjoint events. There's no overlap. Oh boy, let's see if I can undo that. There's no overlap. So let me write that down. Disjoint, or mutually exclusive means no overlap. So you still have probability of being in 7th. Oh, let's do this. Probability of being in 7th or 8th. Probability of 7th or union 8th equals probability of 7th plus probability of 8th. And you can minus probability of 7th and 8th, but this probability of 7th intersect 8th is going to be 0 because there's no intersection. So you can subtract, you can think of it as subtraction if you want, but really all you have to do is probability of 7th and plus probability of 8th when the events are mutually exclusive, disjoint, or in other words, not overlapping. So let's think of, we've got one well, let's do this. I'm going to clear out a little bit of space. So I'm going to clear out this here. And let's just make a joint frequency table just so you can see this. So 7th, not 7th. 8th, not 8th. Something like that. So, first of all, 8th, not 7th is going to be 50. And 7th, not 8th is going to be 40. And neither of those is going to be 10. Maybe there were some 9th graders in the survey or something like that. But what are you going to put in this box right there? It's going to be a big fat 0. So what we have is, looks like we got 40 7th graders, 60 not 7th graders, so 100 people in the survey. And then we've got 50 8th graders and 50 not 8th graders, so again 100 people in the survey. So this time we're just adding up this, the number of 8th graders, and this, the number of 7th graders, and we're not having to subtract out this here. So let's do that. 50 out of 100 plus 40 out of 100. And I could put minus 0 out of 100, but I really don't have to do that because there's no overlap there. So the chance of picking a 7th or 8th grader is going to be 90 out of 100 or 0.9. So hopefully that makes sense to you. You just have to remember the word mutually exclusive, meaning there's no overlap here. So when you have mutually exclusive events, you don't have to subtract the intersection out. Hopefully this helps you understand how to work with the probability of compound events. Thank you for listening in and have a good day. This is Mr. Hansen signing out.